If you've paid any attention to programming languages in the past few years, you'll definitely have noticed a large number of languages who are trying to be C alternatives. If you've used C in any serious capacity for enough time, you'll probably understand why C alternatives exist, but why so many? And if you aren't in this space, it might not make sense at all why C supposedly needs to be replaced despite running on every machine ever and still being incredibly popular. So first, I'll catch the non-C devs up to speed. C is a very, very old programming language, coming around in the early 1970s. The C of this time looked quite different to the C we use today, but the core is still there. C is a very foundational language, but not the most foundational one. A lot of C's ideas came from ALGOL, which introduced ideas like blocks of code and lexical scoping. C took these ideas and perfected them. Pretty quickly, C became a popular language for a lot of projects. Over time, it became standardized, and the standard is still continuing to be revised to this day, with the latest release being in 2024. Still, the roots from over 50 years ago remain, and they're sewn deep within the language. From some basic things, like using null-terminated strings, and not storing the length of arrays, or having stupid amounts of undefined behavior, to much more subtle things, like the heaps of tech debt from the number of different architectures that C technically supports. There are a lot of reasons why people would want to avoid C. At the same time, there are a lot of great reasons to use C. First of all, C is arguably the lowest level cross-platform language. If you wanted even more control over your machine than C provided, you'd almost certainly need to go down to assembly, which doesn't translate between platforms very nicely. Secondly, C is already everywhere. If a computer exists, it can probably run C, so if your program is written in C, your program can probably run anywhere you want it to. Thirdly, C is how programs talk to each other. It's basically the lingua franca of programming. When a new programming language first comes around, it'd be useless if it couldn't talk to C, so just about every language can speak C. When even more languages came around, they all already spoke C, so these days any library that wants to be cross-platform will do it with a C API. The issue with these three things is that they're effectively leaving C's features in a deadlock. Every language expects C's strings, even though they suck. So if your language wants to replace C, it needs to have a good way to handle C's strings. Alongside that, it's basically impossible for a language to have all of the support that C does. Even if you wrote your whole compiler in C so that you could theoretically compile on any platform with a C compiler, the reality is that most modern languages just don't actually want the same breadth as C, and that's the main issue. C is an everything language, and everything languages aren't actually that good. Any language that wants to be fast, minimal, and efficient without making concessions for niche architectures and random limitations needs to have a narrower scope than C. This makes it almost impossible for any one language to fully replace C, and that's probably fine. Different people have different problems with C. It's just the common denominator of all programming paradigms. So, why don't many C alternatives see widespread industry success despite being consistently loved by their communities and often acknowledged as genuinely better? The issue is that if a project is written in C, it usually has a good reason. Sometimes, people just use C because they want low-level control over the machine. These sorts of projects are definitely the best candidates for replacement because they don't necessarily need C for any specific feature as much as the general idea of being a low abstraction language. Different C alternatives take this in different directions, but Zig, Odin, and C3 all do a good job of this. Other people choose C for its simplicity. This one is a bit harder because C's simplicity is a double-edged sword. Many languages choose to move away from C's system because although certain things may be simple in principle, their power often causes problems. Some good examples of this are C's macros or pointer arithmetic. These ideas are all simple and good in theory, but many languages consider it worthwhile to add some amount of theoretical complexity to avoid the practical problems, like Zig's comp time or Odin's multi-pointers. Another thing is that because of C simplicity and a minimal standard library, it's incredibly common for long-time C programmers to have built up hundreds of their own functions and types to use across all of their projects, which makes it hard to migrate away from. So, we know why people like C. What are the C alternatives trying to do differently? Probably the most common change you'll see is some notion of slices. The idea is that we represent lists of items with a pointer to the first item as well as the length. This is the sort of thing people make all the time in C, since C itself doesn't store the length of your arrays anywhere. In a similar vein, strings are often treated as byte slices, which means they don't need to be null terminated. This makes working with strings a ton nicer, since you can take substrings without reallocation. These are basically the minimum quality of life features for any C alternative, since it's the sort of thing most C programmers will make anyways. One feature that's also very common and much harder to implement in raw C is allocators. I have a whole video planned about allocators, so I won't get into the specifics, but the idea is that controlling how you allocate memory is super important, but also a huge pain in C, especially when you want to integrate it with other libraries. One super important feature is generics. While C technically has generics, it really doesn't. You can sort of emulate it with macros, but it doesn't really work that well. Now, let's get into the more specific choices. First up, Zig. Zig is probably the most promising C alternative for projects that aren't actually committed to the C language and just need low-level control and maximum speed. Zig has a very cool property that it can be gradually integrated into C codebases. Zig's maximally explicit syntax and super fine control make it a great choice for projects where every last bit matters. But if you're actually used to C, Zig might not feel great. It actually diverges from C in a lot of ways, and while there is a lot of good arguments for why the changes are good, it really focuses on a somewhat small part of C, which is embedded systems and other related fields. Because of how much control Zig gives you, it could probably be considered lower level than C, which is a pretty impressive achievement. Still, if you're used to C and you switch to Zig, you'll almost certainly feel it. I don't think Zig provides many mechanisms to integrate directly with other code by acting like C. While you can totally make your functions use the C calling convention or make a type that has the C layout, Zig itself isn't overly concerned with being usable as a C API directly, so certain features like error sets and unions don't have a great mapping onto C. Still, you could totally design a solid C API for your Zig program entirely within Zig, which is pretty cool. If you want a language that's built for regular software and still lets you code like C, but you don't mind a bit of a change in syntax, you might like Odin. It's designed to still allow you to write code like you would in C, and a lot of C code can be ported line for line, but it still has all the good features you'd expect from a modern language. The biggest change in Odin, by far, is the syntax. In reality, it's not that different at all, but it does stand out in a few places. The types are definitely different, but for good reason. Odin types are designed to always be readable from left to right, with the name always at the start. In C, function types leave you with the name in the middle, and it's one of the most confusing things in the language. Once you get past the declarations, though, there's really not that much different about Odin. It's not really a language designed for embedded systems or cases where every last CPU cycle matters. It's a language that's comfortable with paying a minor performance penalty for the convenience of certain features, and for most projects, that's totally fine. Odin isn't necessarily trying to be as low level as C, since that's not the C use case it's aiming for. You can definitely get down to C's level if you need to, but average Odin code will be higher level by some margin. Odin also doesn't have a huge amount of interest in being the lingua franca of other programming languages. I know some people would hear those and stop even considering it as a C alternative, and I think that's sort of fair, but it really is just trying to be a language with the same low-level, efficient programming style that C has. It's a modern language with C's features, but it probably won't fully replace C. Last up is C3. Its primary language goal is to really feel like C, much more than Zig or Odin do, to the extent of aiming for perfect two-way interop automatically, which isn't an easy thing to do. It requires the language to make some compromises, and it may be too close to C for some people's tastes, but if you want a language that really feels like C and integrates seamlessly with all of your existing code, it's probably the best option. Because C3 has two-way interop, it's basically at the same level of C. The only real difference is the macro system, where C3 actually does give you a higher level API for the macros compared to C's find and replace macros. C3's two-way interop means it's actually possible for an application to think it's talking to C when it's actually talking to C3, without requiring you to write a heavy amount of interop code. Just attach an export attribute and you're good to go. I think that this makes it the strongest contender for changing your current workflow as little as possible at the expense of still being very close to C. If that's what you want, C3 may be great, but it definitely diverges the least of the three languages. Hopefully this helped you understand why C alternatives exist, and why none of them will ever fully replace C. Still, C is in a pretty good spot. I don't think it's destined to become the next COBOL, since people generally like what C does, and its programming model's stuck. C is easy to learn and to work with, and it's always going to be running on some machine somewhere, if not all of them. That said, C alternatives are still doing great. Plenty of people love Zig, C3, and Odin because they do exactly what they set out to do. There's still reasons to use C, but if you want to move away from it, there are definitely options. I didn't mention any C++ alternatives like Rust, Carbon, V, or Nim, because ultimately they're solving an entirely different problem. I think Rust is probably the best C++ alternative for modern C++ because all they're trying to do is awkwardly shove the Rust language features into their intended library, and that's how you end up with that nightmare of a language. If you want ownership, borrowing, traits, ADTs, and good move semantics, placing them in the language itself is the only good solution. By the way, this video idea came from a comment that I got, so if you want me to talk about something else that interests you, just let me know.